Hey everyone, we're going to talk about Unit 2, Lesson 2, which is about the distributive property. The distributive property can be written as the identity A times B plus C equals A times B plus A times C. So it's called the distributive property because you can think about the way that you get from the left side to the right side is you distribute the A to each term on the inside. So that's A. Out here it's really A times all this stuff. So you do A times B. That's how you get the first term. And then you take the plus sign, plus, and you do A times C. So the things on the right side of this equation, the expression on the right side equals the expression on the left side because of the distributive property. The way that looks, if we see some examples, is here are examples A, B, and C under example 1. 2 times x plus 1 will look like this. 2 times x plus 2. Because you do 2 times x, and then you do 2 times 1, and you add those two things together. Letter B, you get 5 times 8x, which is 40x, and then 5 times positive 3, which is 15. Under C, you get 10 times 2c, which is 20c, plus 10 times 5, which is 50. And so, example 1, everything's positive, so you don't ever actually have to worry about where the negative signs are. So let's look at some with some negative signs in example 2. Example 2 has 3 times 4f minus 1. So 3 times 4f will give you 12f, and then you can think about writing it as plus 3 times this term, which would be negative 3, and then you can rewrite this as 12f minus 3. But what I usually do is I skip that middle step because I know that the 3 is negative, and so I know that the final term is going to look like final expression is going to look like 12f minus 3. So what that looks like in example B would be 9 times negative 3r, which is negative 27r. And then I see that this is going to be negative because the 9 is positive, the 11 is negative. So I just write the negative sign and I do minus 99. If that is skipping too many steps and you don't want to skip that many steps, then the way that you would write it is 9 times negative 3r, that's negative 27r, and then just automatically put a plus sign, and then do 9 times negative 11, which is negative 99, and then you can rewrite, on this line, you can rewrite that so that you get 27r minus 99. But we end up in the same place, whichever way you want to do it. All right, example 3 shows some, and division is really the same thing as multiplying by a reciprocal. Remember when you learned how to divide fractions. So I can rewrite this expression as 6x plus 15, all that's in parentheses. And if I divide this by 3, I can write that as dividing by 3 like a fraction bar. And then it works very similarly to how the multiplication worked. You just divide each term by 3. And you distribute the 3 to each term. Instead of multiplying, now we're dividing. So this will give me, so 6x divided by 3 is 2x, and then 15 divided by 3 is 5. On B, that would be 2b divided by 2 will give me b, and 12 divided by 2 will give me 6. And so right there, I skipped writing it as a fraction, and I just thought about what I would get if I divided each term by 2. But you could have written it as a fraction first. So 2b plus 12 divided by 2 will equal, what's 2b divided by 2 gives me b, and 12 divided by 2 gives me 6. All right, C, 20r minus 8 divided by 4. That will give me 20 divided by 4 is 5, and the r stays with it. Negative 8 divided by 4 will give me negative 2. And so, just like on the multiplication, each term gets divided by the thing outside parentheses. So 49g divided by 7 is 7g, negative 7 divided by 7 is negative 1. Okay. Example 4 says expand the expression. And so now we have more than just two terms. Everything on the last page, there were only two terms inside each parentheses. 1, 2. But now there's 1, 2, 3 terms inside the parentheses. Really nothing changes. There's just a little bit more distribution to do. So here it's 4 times x, which is 4x, plus 4 times y, which is 4y, plus 4 times z, which is 4z. With some negative signs in there, it'll look like this on example B, 4b. So that's 3 times x, which is 3x, 3 times negative 2y, which is negative 6y, and then 3 times positive 10z, which is positive 30z. Now, the next section under example 5, it's like going backwards from what we've been doing. In example 5, if you look at example 5a, there are no parentheses here, and my goal is to go from this expression back to one where there are parentheses. And the steps that you can follow to get that done are right here above it. First, determine the greatest common factor of all the terms. So 72 and 8. The greatest common factor that 72 and 8 have is 8 itself. So we did that. It's 8. Now divide each term by the greatest common factor, okay? 72t divided by 8 is 9t. 8 divided by 8 is 1. And notice that I'm writing it just like it was above with the same operations, except I've written it after I divided each term by 8. So instead of 72t plus 8, now it's 9t plus 1. If I stopped here, this would be a totally different expression than the one above it. So I don't want to stop here. What I want to do is then rewrite the expression with the greatest common factor outside the parentheses. So the 8 out here. Now, if I think about distributing this, 8 times 9 gives me 72. 8 times 1 gives me 8. Now this expression is the same as the one that I started with. So I didn't change the value of anything, I just rewrote it as the product of two factors. All right, in B, the greatest common factor between 55a and 11 is 11. So if I divide both terms by 11, I'm going to get 5a plus 1. And then I write the thing that I divided by, 11, I write that outside the parentheses. In C, example 5c, the greatest common factor between 36z and negative 72 is 36. So I'm going to divide each term by 36 and then write 36 outside the parentheses. So 36z divided by 36 is z. Negative 72 divided by 36 is negative 2. And then I write 36 outside the parentheses. D, the greatest common factor of both of these is a 3. And so if I divide both sides by 3, both terms by 3, I get an R and an S inside the parentheses. Number 6 says simplify and write in standard form. So example A is negative A minus 2 times A minus B. And there are parentheses here. And so we're combining multiple things that we've seen. You saw last week how to combine like terms. And now you're going to see how to distribute first and then combine like terms. Because there's an A on the inside and there's an A out here. But because of order of operations, we're not multiplying by a negative A minus 2. This is a totally different expression. There are no parentheses out there. What we're multiplying is negative 2 times A minus B. That's the multiplication involved. The negative A is separate. Negative A is a separate term from the negative 2. So you don't include the negative A that's out here when you distribute the negative 2. So negative 2A is the first term because it multiplies the A. Negative 2 times negative B is positive 2B because the negatives cancel out. But this is still here out front, negative A. And now I have two like terms that have A's in them. And so I can combine those to get negative 3A plus 2B. Another example is 2W plus 3 times negative 2Z minus 3W. So there's a bunch of numbers here, but it's the same process we've been seeing. So I know that the 3 is the thing that I'm going to distribute because 2w is a separate term. That's not part of the term that's being multiplied by the parentheses. So I'm just going to bring the 2w down, and then I'm going to put 3 times negative 2z is negative 6z. 3 times negative 3w is negative 9w. And now I've got some like terms I can simplify. 2w minus 9w is negative 7w, and then minus 6z. All right, and now there are some homework on page 45 that you can complete now that you've seen this lesson.